Hey guys, this is Sujay Ram, and here is Philip Babbage from Croatia, and he's a Google developer expert for Android and Kotlin. And today's event topic is how to get started with Kotlin. You can submit your questions in the link in the description. And yeah, let's get started.
Awesome. Let me just share my screen real quick.
Yes, sir.
Where is it? Okay, so I think everyone should be able to see my presentation in a moment, if not right now.
It's visible, sir.
Yeah, awesome. Thank you for joining this presentation. I'm really happy to be able to hold something for you and kind of talk about the programming language of Kotlin. This is one of my favorite topics because I love talking about Kotlin and its features and how awesome it is, and how better the Android ecosystem is. Well, the whole of JVM, I guess, is because of the language. As you heard in the introduction, my name is Phil Babic. I come from Croatia. I live here as well. And I'm a Google developer expert for Android and Kotlin. If you're not sure what the program is about or what that means, you can just kind of send me messages on LinkedIn or Twitter or email, and I'll kind of explain it to you. But basically, this is like a group of people who do a lot of community work, a lot of public speaking and things like that, and are considered experts in some of the categories. For example, for me, it's Android and Kotlin. I also run the GDG OSEC here in Croatia, and a bunch of smaller other local community engagement stuff. So you can find me in many different events talking about different topics. So I'll hopefully be able to join you somewhere in the future as well. So today I'll talk about Kotlin, about an intro to the language, and more specifically, I'll talk about what Kotlin is, like what kind of a language it is, what types of programming paradigms does it support, how do you get started in terms of writing the code, what the basic syntax is, and things like that. So there's quite a lot of things to go through the presentation, and hopefully we'll be able to do it in an hour. But let's jump into it and talk about what Kotlin is. So it's a really modern programming language. It's supposed to be a general purpose style language. So this means that you don't have any constraints in what you can use Kotlin for. Basically, if you want to use it for Android, which is kind of the most used part of Kotlin, I would say, or like the most used context, then you can do that. You can also use it for backend development. Wherever you used to use Java, you can use Kotlin. Now there are some specific Kotlin frameworks and platforms that allow you to support multi-platform, the development for desktop, for the web, for even iOS to some extent, and things like that. Let me just hide this real quick. And this means basically that whatever you think about, whatever platform you think about, you could probably write it in Kotlin. And this is supported by the Kotlin native initiative and project as well. It's statically typed, which means that there's a bunch of compile time checks, and as you write code, you have a strong type system, which means that you don't have to worry about errors or crashes or bugs happening because you wrote something that shouldn't have been written. For the most part, you have a really strong system that enforces you to write good code, and in pair with development tools such as the Android Studio and the IDEA or the JetBrains set of tools that you have at your disposal. You're able to write really good code really nicely with a lot of clean checks to help you write polished and optimized code. One of the things that stands out in Kotlin is that it copied a bunch of features from different languages, such as Java, C#, Python, Scala, a bunch of other languages actually. And this is one of the best things, I would say, because Kotlin is not completely unique and completely new. It didn't go in that direction where they just started writing a new language and they wanted to make everything completely new. Instead, they looked at and JetBrains, the company behind the team, looked at other languages to see what they're good at. And in turn, they use those features to improve Kotlin or to build features in Kotlin, which are really, really good. And this means there's like a bunch of things, that you can do in Kotlin. And you can do it, as I mentioned, on the JVM, which is basically, anything that runs on the Java virtual machine. So Android to most extent, Then you have backend code, Java-based applications or JVM-based applications similar. You can also write Kotlin for JavaScript and for native, as I mentioned, so for multi-platform. This has actually changed a lot in the last year or two, basically, with more support, and now you can use the Kotlin natives project to actually build multi-platform features. It has super awesome mobile support, and it's constantly being developed. So there's a lot of things you can do with Kotlin, but it's primarily on the JVM. One of the things that makes it so awesome is that it has really strong, or like 100% Java interop, which means that you can write Kotlin code and use it in Java, or you can write Java code and use it in Kotlin. You don't really have to do a lot of work to make things work between those two languages. It kind of does it on its own. So this was really important when introducing it to Android or to the backend ecosystem, because Java has a really good set of tools and libraries. And obviously, if you want to introduce a new language that's supposed to, I wouldn't say replace Java, but offer something new to everyone who uses Java, then it's really important for you to be able to work with Java as well. It's really concise, which means that you can write just a small bit of code and actually produce a ton of features. You don't have to use semicolons or anything like that. It's really short. You don't have to worry about redundant statements. You can code things outside of classes, which means that you have top level code such as functions and objects and classes and constants or values. Being first-class citizens means that you can write them anywhere. You can write them in outside of classes. You can also use them in a complex way. For example, you can use functions as parameters to other functions, which is something that's a bit more advanced, so to say. And it's pretty easy to use. To actually get started with Kotlin, you need the JDK, which is the Java Developer Kit. You usually have this bundled in your IDEs, so such as the IntelliJ IDE or Android Studio. So you don't really have to worry about installing this yourself and then going through it and setting up all the kits. Most of the time, you can just install the tool, and it will be allow you to install everything out of the box and use the language right away. So let's go over some of the basic syntax points in Kotlin. One of the things that people usually start with are values and variables. So, like, how do you declare values or variables, or is there a difference? What's one versus the other? So basically, there are like a couple or three different types of data points you can create in Kotlin, so to say. The first is the value, or which uses the val keyword, which means that you can't reassign the value once the value is set. So it's similar to what final is in Java or some other languages. But basically, this means that you use this for anything that's not going to change, something that's really set in stone, that you don't have to worry about changing in the runtime and then breaking your code. You have vars or variables, which you can change the value of. You can reassign it at any time. So this is like your traditional variable. And finally, you have const or constants, which is basically a value that is known at compile time. You can't create any custom getters for it. You can't. You usually can use just strings or primitive types, because those things can be compiled easily, as opposed to some of the dynamic structures such as lists or arrays. And you can, or you have to declare constants within either top level areas, or such as outside of a file, or within a file outside of a class, or within a companion object, which we'll get around to in a moment. So here's a couple of examples of using values and variables in Kotlin. Here at the very top, you can see the val name string equals John Doe. So this is another thing that's different in Kotlin as compared to Java, which is the type of value or variable comes first. So first you say, or like the mutability of it comes first. So you say if it's going to be a val or a var, then you put in the name, and finally you put in the type using a semicolon. And in the end, if you want to assign the value right away, you can do so. So here it's really important to know that you can omit the type, as you can see here. you can omit the type because the language has something called type inference, meaning that it knows that this is an integer. It knows that this is a number, and you don't have to say explicitly that this is an int like you did here. Another thing here is that if you're using vals, you cannot assign it later on. You have to assign it right away in sorry, in line. You can't change the value later, so this is not going to work basically. And you can, as I mentioned, you can omit the types if you know what the type is, if it's really clear what the type is, which is a really cool thing because you can shorten your code and make it more readable for most part. Now, after learning about what values are and variables, then you obviously want to go through functions, which is the next complex structure, so to say. Functions in Kotlin start with the fun keyword, which I guess is like a small joke, as the language is really fun to use. Then you have to declare the function name, its parameters in parentheses, just like with other languages, and finally the return type. And here's an asterisk because you don't really have to declare the return type. We'll see how you can use something else called an expression to actually just return the value instead of declaring what the return type is. If you have a body, you don't need to have a function body. You put it within curly braces, and again, with parameters, it's the same as with values. You first declare the name of the parameter, then you follow it by its type. So here's a really good example where you have a function called print message. It receives a parameter or argument of the type string, which is called message, and it returns unit. Unit is basically void. It means like it doesn't return anything or any special value. So it's something that's by default here, and you can actually omit it. And then you have your function body. Sorry. Then you have your function body within the curly braces where you do whatever code you want to do. Notice that you don't have to use semicolons, which is really, really cool. And functions are really great because you can write them in different ways. Like you can have default arguments, which means that if you don't want to send a specific argument, you can use some default value. It's very useful when you have like a bunch of arguments, and some you just don't have to send, some you don't really care about, some you want to have the default value and only change if the user wants to. So it's really helpful in those cases. You can also use named arguments when calling functions to explicitly say what you're passing in as a value, as an argument. You don't have to follow the parameter order, which is really cool because if you have, again, like 4 or 5 different parameters or arguments, you can just order them in whatever way you want or whatever way makes sense for you. So here's an example of a default argument or default parameter where you basically say, okay, if I don't want to send the message here in this print message function, I'm going to use default message as a string. So basically, you can just call this function and not pass in any arguments like so. And it will output default message, which is whatever it is within the default arguments, which is really cool. Or if you want to actually send a message in, you can send the hello world message here, for example, and it will actually print that out. So basically, it looks at like you have in Java, you have multiple constructors. It looks at which version of the function you called. Is it the default one, or with no arguments, or however many arguments, or is it the one with arguments and then it uses the values to do different things based on the actual values you passed in. There are also a bunch of data types that you can use in Kotlin. Obviously, you can define any number of custom types, but there's something different in Kotlin as compared to some other languages where all data types have the object style of naming, so to say, where they start with, they're capitalized, and they act as if they are objects. So even though they are primitive types, actually, so they have runtime performance optimizations with boxing or inlining or things like using a number as an int object, but it's actually using an integer value and not an object. That's called boxing and unboxing. So basically, you have types such as int, long, float, double, boolean, string, like characters. and a bunch of other types that you can declare, especially if it's like lists or dynamic structures or things like that. And basically, this means that if you use an int, you're going to use it as an object. It's going to behave as an object, so to say. It's going to have functions on it and things like that. But it's actually going to be an integer number. It's going to be optimized, so there's no performance overhead. So here's like a couple of examples. You have the val age, which is an integer. It's equal to 25. So you can see that it's int with a capitalized I and not, or capital I, and not a small I. The same for other objects. And another thing that you can use, which is like the underscore, I guess, as delimiters to format the numbers a bit nicely. You also so doubles are declared by just using the actual dot separator, or like a decimal point. And if you want to use floats, you can add just the float suffix at the end, so the language knows that it's a float and not a double. So it's really not easy to use numbers in that sense. And some other values, as you know, Boolean is pretty much true or false. So you can use Boolean just like in any language, and you can use strings and characters just like in any language. So that's pretty clear and pretty simple. But you notice that they all have capitalized type names, so that's a bit different. Strings are really cool because they are an array of characters, right? So you can use the index operator with brackets, square brackets, and just access any element within a string, which is really cool. You also have different things like escape strings, where you can put in values based on runtime values. Put in text into a string based on runtime values. You can also use raw strings. You can combine them using the concat operator. You can use string templates, which is really cool. You can also iterate over string elements. You can create multi-line strings. So there's just like a ton of things that you can do with strings, which is something that we use most often. So for example, we can have two strings here and concat them together into like a full name, into a full string value, which is really cool. But another thing that we can do here is called string interpolation or string templates, where you actually say, okay, using the $sign, I'm going to require a name value or variable that's going to be put in here, and it's going to look in the program scope, be it a function or the class. It's going to actually use this value to put into this place, and the last name value from here to put into this place, and it's actually going to output John Doe here, formatted in the way that you want to format, which is really, really helpful and something that you will probably use all the time. As I mentioned, you can access specific parts of the string using the index operator, which is extremely helpful. You can loop over different elements in strings and in any collection, basically. And this is really cool because you can also see like how easy the iteration is. You just say for each character in a language, let's do something, and this is one of the things that other languages have as well. But there are different ways how you can iterate over collections, which we'll go over in a bit, I guess. And the final thing, as I mentioned, is you can escape stuff, which is normal. Like you can use just the backslash, if I'm not mistaken, and you can just escape things, or you can use triple string literals to have multi-line strings, and you can format them in whatever way you want, which is really, really helpful. Again, if you have long texts and you just want to format them in a nice way, and you want to have it really visible to you what the final output is going to be. So as I mentioned, there are a couple of things that you can do with like collections, with if and else cases and things like that, which is called the flow of control or control of flow. Basically, this refers to any number of operations or statements that you use to switch the code that you want to run based on a condition. We have the basic if and if else value statement in Kotlin, but it's also something that can be used as an expression. An expression basically means that you can use control of flow or flow control, such as if-else statements, when statements, try and catch blocks, and so on and so forth, to return values, meaning that the last line of code in that block is going to return the value. So let's see what that actually means. So the traditional usage here would be to say, okay, the max value is equal to A. If max is lower than or like less than B, then max is equal to B. This is a small traditional use case that you can do, but you can also do something like this. You can say, okay, we'll declare a max variable and we'll assign it based on the if and else case. However, you can use an expression saying, okay, the max value is equal to if A is more than B or greater than B, then A, else it's equal to B. So basically you're using like a shorthand if and else expression to assign a value. And this is really cool because it's like a ternary operator, but it's much more readable. You can have it be much more complex without having to chain multiple operators. You can just have if and else statements. Another thing that you can do is use the when expression for a similar thing. So basically it's similar to switch in its syntax, but it allows you for more complex comparisons. Like you can compare the argument you pass into when, if it fits into any range of numbers, if it matches a type, if it matches a specific value, and you can also use it as an expression, and you can use it for default cases by using the else block. So here's an example of what a when statement looks like. You can say, when the name variable is equal to Luca, I'm going to print the following statement called my name is Luca. You can see how using the arrow, basically you're saying if the name matches this value, then do the following statement. The same if it matches this, and so on and so forth. And then finally you can have an else block, and you can also use curly braces if you have more complex statements. So this is a really nice way of using like a switch case, but it's much nicer compared to the actual switch statement, I would say. And you can also do you can also do checks like this, where you can say when age, which is a number, is within this range. So you can say if it's in the range of 0 to 18, then I'm underage, else it's something else, I'm an adult. Or you don't have to pass in an argument to the when statement. You can just do any number of checks you want and format them in whatever way you want. So basically, this means that it always has to refer to a Boolean value, which in this case is the number is odd check or the else check. Or you can pass in a value to the argument and then compare to something else and also get a Boolean value. And you can also do type checks, which is really easy. You can just say I'm going to pass in the x, which is any value, and also notice that the any value is basically the object from Java, so it means any value essentially. And if that any value is a string, I'm going to do this. Otherwise, I'm going to return something else. And this is a really good example of how you don't have to tell what the return type of a function is. You can just use a statement to return something. You can just say this function equals to the following statement, and then it's going to resolve this statement every single time. And you can omit the return type, which is a really, really, really cool syntax sugar. So let's go back to loops and handling iteration and things like that. It has the basic for loops, so Kotlin has basic for loops, but they are not so basic actually. You don't have the very traditional one where you count through indices or something like that. You actually have a more modern approach to loops. So the simplest way to iterate over items is saying for each item, or this can be whatever name you want, in a certain collection, let's print some item. You can also rename it to I if it's something that makes sense for you, like an index. You can go through ranges. This is called a range of numbers from 1 to 10. You can also say for each value in 1 until 10, which excludes the last number. So this is going to include the 10. This is going to exclude the 10, or go up to 9. You can also have ranges or iterations which go down from a number. So instead of going up or like incrementing the value, it's going to go up. So you can say for each value in 10 down to 0, you can also add a step of every 2 values. So you can like step or increase by, instead of saying I plus plus, so to say, you would say I plus equals 2, right? So every 2 numbers is going to be the iteration. So there are different ways you can do loops, but there's no traditional loop where you say for e, like the variable I equals 0, I plus plus, blah, blah, blah. You don't have that. You only have these kinds of values. But you have some different things like while loops that you can use, which are more similar to that. The while loops is pretty much the same as, in any language, you say while some condition is true, let's do something, and then you reduce that value or increase it based on your condition. Or you can use a do while statement, which is the same, except there's like no semicolon at the end. So it's pretty much like any other language where you say, I'm going to do this thing while some value, matches my condition. And once that value doesn't match my condition, I'm going to stop the while loop. Another really popular thing, or like one of the most important things of Kotlin, is its nullability handles. So Kotlin actually has nullability built into the language itself, which means that there are specific values which are called nullable values, and also values which are called non-null values. Nullable values are obviously values which might not exist or might be null. And if you try to access a null safety value, or sorry, if you're not accessing the value in a safe way, you're going to get a null pointer exception. But because we have this complex nullable or nullability system built in, we have a ton of compile time checks that you can't access null values unsafely. You actually are forced to add specific checks like safe call operators or Elvis operators that return a non-null value. So basically, you never should get a null pointer exception in Kotlin if you do things correctly. And here's how it looks. So basically, you can say, I have a value called name, and it's a string. I want to assign null to it, but I can't because it's a non-nullable value. You can see that there's a string. It only says string. But if it says strings with a question mark, then it can be nullable, and you can assign null to it. You can also see the compile time checks, which this is going to break your builds. You can't compile the code until you fix the actual problem, which is basically what most languages try to do, but you have to do the checks yourself. Then you have the safe call operator where you say, okay, I'm going to assign a null value, and I'm going to try to access the last name and its length property. But I'm going to use the question mark dot or the safe call operator, which means that this is going to try to return the length. But if anything before the length call or the safe call operator is null, it's actually going to return null. So in this case, this would print null. But if if the last name string question mark is something else, it's not null, then it's going to actually print the length. So it's a really smart way of dealing with null values. You can also do something like this, where you say, okay, I don't really care about the nullability. I'm just going to use the force operator, which is double exclamation point and then a dot. This is something you should never do, basically. This is like a bad practice if you want to, if you want to go around the nullability system, but you should never really do this because it creates bad practices. Now, obviously, there might be cases where you might have to force a value because you know that it's not null. But again, there are different ways you can do that, more safe ways, let's say. So this is going to crash in this situation. But if the value is actually not null, it's going to be it's going to work fine. And for those cases, we have the Elvis operator. So instead of forcing null values, you can do something or use something called an Elvis operator. And it's called like that because if you tilt your head to the side, the question mark kind of resembles Elvis's hair. That's supposedly why it's called the Elvis operator, but who knows? Basically, it says if my expression or the condition on the left is null, then return the right-hand side, or like whatever is right from the Elvis operator. If the expression or the condition on the left-hand side is not null, then return the left-hand side. And this is what it means. So basically you say here you have like a name, which is a nullable string. You can try to print the name length, but this is going to print out null. But if you use the Elvis operator, you can say, okay, the length is the following statement. So it's going to be name save call operator length or 0. The Elvis operator says or 0. So if this returns null, it's actually going to return 0. And if it doesn't return null, it's going to return whatever this value is. So this is like a safe way of dealing with values. You don't have to worry about creating special null checks or anything like that. You can just use an Elvis operator and return something in default, which is really, really cool. So let's go back to the actual basis of the programming language, which is for the most part it has object-oriented programming features, but it also has some functional programming features. So let's go through that real quick. So classes in Kotlin are pretty much the same as in other languages. However, the syntax might be a bit different. So you use the class keyword, of course. You define the class name, the constructor parameters, if there are any, if you need any parameters. If not, then you can omit the constructor. And you also can omit the class body if you don't have any class body, like any logic, any functions. And this is really important because there are specific types of classes that help you initialize data, which are called data classes, which I guess we'll go over in a bit. But basically, you can omit a bunch of things. And like the most basic class you can have in Kotlin is just saying, this is a class and this is its name. So like the very, very basic. You can also have a constructor, as I mentioned. It's in line with the class. And you can omit the constructor keyword because you don't use any visibility modifiers. Basically, the default visibility modifiers for everything is public, which I kind of forgot to mention. And everything is final by default, so you can't override it. So you can't override the class, you can't override any functions. If you want to override something, you have to have the open keyword at the very start. And the shorthand for this constructor is basically the construct saying class course, and this is the value that it has. It has like a name property. And this is actually going to be bound, bound to the class. So you don't have to create like a property and create a setter and a getter. You basically have everything that you need here. So you can have different types of constructors or like multiple constructors. You can have an init block. You can have methods or functions, as they're called in Kotlin, properties, object declarations, and nested or inner classes as well. So let's go through that real quick, I guess. Sorry. So you don't need to define a constructor. You can just use the empty constructor that by default. But if you want to declare it, you can use that, especially for properties. You can have multiple constructors, whereas the first one, the one that's in line with the class, is the primary constructor, and everything else is the secondary constructor, and you have to declare it within the class itself, within the class body. And every secondary constructor has to delegate its parameters to the primary constructor. So it's similar to calling super in Java, but you call this instead. You refer to this class and its primary constructor. If you want to have init blocks, they are cool because you can initialize properties later. So you just say init wherever you want in the class body, and it's going to run that code whenever it reaches that code. So basically, it goes through the class sequentially, and if there's an init block, it's going to run that code. And it also runs right after the constructor initialization, but in the order that you define them. So for example, we have something here called a class named student. It has a name parameter and a last name parameter. Notice that there are no val and vars here. And it has the private file full name string. And you can use an init block to actually create this value. And it's going to use these two parameters to create that value. So this is like an example of what you can do in Kotlin using the init block. Another thing that you can do is you can say, okay, I do have the val name and the val area square kilometers for a country, and I have a special constructor which just passes in the name, but it doesn't pass in the square, like its area, because you might not know that. This is a secondary constructor. This is the first, like the primary one. So this means that you have to delegate the second parameter to, unless it's a default argument, to country using the this keyword, like you're calling the not super constructor, but basically the primary one. And this is called a secondary constructor. So this is like this section defines that this is the secondary one. And this is the actual part where you delegate any number of properties to the primary constructor if you want to initialize something, or you have to pass in specific parameters. Now, in terms of objects, sorry, in terms of objects, these are instances of a class, obviously. So you can create objects as an instance of a class. You call the constructor to invoke the class itself and then create objects. So it's pretty much the same as you do in other languages, but you also have some differences. So you don't have to, again, declare the return type or like what the type of the value is. It's just going to know that it's a country. And you can also use like, different parameters based on your constructors. And you can also use default arguments if you have in the constructor itself. And as I mentioned or hinted before, you can have class properties. And instead of creating them yourself, like manually, like creating a property and then a setter and a getter, you can have as many properties as you need in a class, and you can directly assign them in the constructor. So using the var and val keywords. So you can do something like this. You can say, I have a class named course, and it has these three values within its primary constructor, meaning that this class has three properties as they are defined directly in the primary constructor using val or var, and it's going to be bound to the class. So you can just say, I have an Android course named Android Development Course. It has 10 lectures, 20 students, and this is what it's going to look like. And these are all properties that you can use within the course, and you can actually access them directly by saying, I want to, using the object that I have, I want to access the name, which is here, the number of lectures or students, which are here. And it's going to print out the actual value. So it's like using property access syntax. It's not using getters or setters. It's actually directly accessing the value, which is really good. And basically, like the properties have default getters and setters. And this is like, you can define properties in this way, and you can define them in more complex ways by using like custom getters or setters. So you say, I have a property within the class itself, not the constructor. This is its type. This is its like initializer. If it's like something that you want to initialize right away, you can also define like a custom getter and a custom setter if you want. So you just say get equals something else, or set with a value. You can set it. But you don't have to create these fields directly. Like it doesn't. For the most part, it doesn't make sense, or it's more work than you actually need. You can just use the original field, like you can use the original field name as a getter, or if it's a variable, you can use it as a setter. So instead of creating these things yourself, you can actually directly access the field, which is called the backing field or backing property. And it's not like it creates these getters and setters for you, so to say. So you don't have to create the getters and setters yourself. So here is an example of what a custom getter or setter might look like. You can say, when I get this value, I want you to return some field, or this field actually refers to the name. Or you can say, when I set with some value, I want this field or the name property to be set to the value. Or you can use like something like here, where you can say, if the population of a country is more than 0, then set it to, you can have conditions within the setter, which is really cool because you can sometimes add conditions to fix values that don't make sense, like negative population doesn't make sense in the matter of a country. You also have late init variables, which are variables that you don't initialize right away. You use the late init modifier, and basically these are good for some cases where you just can't directly create them, like you have a bad life cycle, you don't or like a life cycle that you can control, You can create them at the very top of the class and then initialize them later. But they have to be non-null, or they are non-null by default, and that they can't really be primitive types. They have to be like object types or class types, so something more complex. And if you try to access these variables, you get exceptions. So for example, you can create a latent var here called course, which is of the type course. And you can have checks where you say, if this course is initialized, then do something. Otherwise, it would crash if you just try to access course.name, because the property isn't initialized. So this is really important to make sure you don't forget. And then finally, or like somewhere near the end, I guess, we have companion objects, which are special blocks in classes. And this basically represents static code within classes. So like static blocks in Java, or static functions or variables. Basically, this represents that within a class. So you can have a class named course fragment, which has a companion object, which is called, basically this is the name. It's saying the name of this object is companion object. You have its block, and whatever is within the new instant, or within the companion object block, is going to be static. So this function new instance, which returns a new course fragment, is going to be static, and you can just use it in the same way as you would use any static variables, like saying course fragment dot new instance, and it's going to create the actual object itself. Is going to call this function. And finally, visibility modifiers. I know this, I know that I haven't gone through things like collections, lambda functions, and all that, because that's the functional aspect of Kotlin. So we might have like a series of presentations actually, and this is because there's a ton of content on Kotlin, and it's really hard to go through everything. But basically, to kind of wrap up the very basics, I would like to talk about visibility modifiers. So everything is public by default. Everything, whenever you don't have a visibility modifier, something is public. If you want to have something private, you just add private. Protected means protected within the class or its subclasses. So this is for inheritance. And internal means within the same module. So this is a bit different as compared to Java and things like that. This is really useful when you have multiple modules in a project, like in an Android project. Where you just want to have some functions which are visible within that module and not outside of the module, basically. So this has been quite a lot, and as I mentioned, there's a bunch of other things that I wanted to cover, but the presentation is just quite long by itself, and also there's a bunch of other things that we need to go through, and different aspects of programming and things like that. So hopefully I managed to kind of go through things in a nice way, that things are clear, that it kind of excites you to use Kotlin. So thank you for listening to the presentation. And I guess I would ask, usually, are there any questions? But we do have some questions in chat, so we can go through them. But if there's anything else, you can just let me know. So yeah, how can we initialize an array in Kotlin with a value? So I'm guessing that you mean initialize an array with specific values in mind. You would just use something, or let me just open something real quick. You can open the IntelliJ and just kind of show you. Yeah, I've done this before. Why is it different? Sure, untitled. Okay. So I can just show you real quick how some basic Kotlin functions look like and things like that. So if you want to create all right, and let's zoom in here if I can or not. If you want to create an array in Kotlin, you just say while my array equals array of. Does it work? Basically, my syntax is highlighting is kind of not working. But basically, say array of, let's say 2, 3, 5, 10. You say I want to create an array of these values, and basically that's it. You can also use strings, as I mentioned, or something else, different numbers, like 3 floats, something like that. But basically, you just use the array of function. You have a bunch of these. You can have list of, you have set of, you have map of, you have mutable map of. So This is why I kind of didn't cover these things in this presentation, because there's so many. Like when you want to create a mutable collection, you have mutable list of, map of, set of, and so on and so forth. You can use arrays like array list of, empty array, byte arrays, like things like that. So there's just a ton of different things with collections and like the functional aspect of Kotlin, which is really hard to cover in one presentation. So it would be really nice if we had like a series, so I can come back again and talk about these things specifically. So hopefully this answers your first question. Question 2, what is the disciple operator? I'm not sure what you mean. Like we didn't mention disciple operators. Maybe you think about the Elvis operator, like where you say val or like you have something like name, string, and it's null. You can say name len, I guess, sorry, is equal name length or 0. So basically here you say, I want to return this value, or if it's null, I want to return 0. This is called the Elvis operator. I'm guessing that you asked about this because I'm not sure what the disciple operator would be. I'm not sure what that means. And basically when you print this, you just say name length. Okay, name length. Not sure why. Oh, sorry. I managed to break my code real nicely. So basically you can print it, and this is going to actually print 0. But if I were to say Philip, this would print whatever the number of letters is, which is probably 5, right? So this is how it works. It's going to either return whatever the value is, or if it's null, it's going to return 0. And the val keyword basically means that you can't reassign this. So let me just kind of remove this real quick, and I can say val name equals Philip. If I try to say name equals, Marin or something like that, this is actually not going to work because it says vals cannot be reassigned. This is a value that you can't reassign. But if I were to put in var, you can see that it's underlined, and you can see that it can be reassigned. So if I were to print the name here, it would print out Philip. But if I were to take the same thing and kind of print it after this, it's actually going to print Marin. So this is the difference between vals and vars. You can't change vals, but you can change vars. So hopefully that answers your question. Do we have any other kinds of questions?
No, so there is no more questions.
Okay, awesome. So let me just close this down real quick and close the presentation. So basically, I can share this presentation with you via the link, so you can take a look at it again if you want. You can use this like Twitter handle if you want to reach out to me. But I can actually share more information. Like you can reach out to me via my email. You can reach out to me via LinkedIn if you have any kinds of questions. I also offer like mentoring. If you need some help on things, I can try to jump in a small call and talk to you about it, and help you fix the problem, I guess, or fix the issue. Or if you're just interested in learning some new things, you can reach out to me, and I'll try to explain some things to you so you can learn them. You can basically, I'll just stop sharing real quick because it's easier for me. You can reach out to me via different ways. So yeah, I mean, I'm more or less always available. So if there's any kinds of questions afterwards, if you think of something new, you can just reach out to me and ask me those questions. But if not, thank you for being here and listening to me.
Thank you everyone for viewing the event, and thank you everyone. Let's see in the next event.